Hello, Math 1A students. Mrs. Robinson here to work practice benchmark chapter 2 with you. You can come here and get help if you need. Let's start with the first one. Sketch the graph to represent this situation. The average temperature steadily decreases over the course of a football season. So we're just looking at time passing and the temperature decreasing. So if I just create a little axis here, I'm going to go time here, and let's do our time in months or maybe in weeks. You could do just time if you want, over months. And then over here we'll do our temperature. Okay, so it might look something like this. As the football usually starts in the fall, like August or September, and it ends in November or December. So if you want to do time here, like if the month was August, the temperature is going to be really high. And then as time goes on, September, the temperature gets a little cooler. It's still pretty warm in Southern California. October, a little cooler. November, a little cooler. So it might look something like this. This is what you might look like for the football season. Of course, it would get warmer again, but the football season ends when it's still winter. So that's what that one would look like. How about this one? You buy 2 shirts, the third one is free. So let's make a little graph here. And we'll do the number of shirts we buy will be related to the cost. So we'll do shirts here, because the cost depends on the number of shirts. That will be our Y. And then we'll do cost here. Okay, so the number of shirts you buy. So if you buy 1 shirt, you're going to pay however much. Let's say you pay, I don't know, we're not giving exact amounts. You pay a certain amount. You buy 2 shirts, you pay that same amount. But you buy the 3rd shirt, you're not going to pay any more. You're just going to pay the cost of 2. So it might look something like this. 0 shirts, you pay $0. 1 shirt, you pay, say, $10. 2 shirts, you pay $20. The 3rd shirt, you're still paying $20. So it just comes over like this. And that's what that would look like. All right, let's go on to number 3. All right, number 3, for the table, identify the dependent and independent variables. Describe the relationship using words, an equation, and a graph. Make sure you do all the things that ask you to do here. So here, my independent and dependent, if this is my x and this is my y always depends on what I choose for x. I'm going to plug in 0, and then it's going to give me out a 1. So this is my independent. I just pick it. And then the y depends on the x, or the m depends on the n, okay? So this will be, so I'm going to identify that here, independent, dependent. Now I'm going to describe the relationship using words, an equation, and a graph, 3 things. Well, let's first figure out the relationship. Let's see how y changes. It looks like my m, looks like my n goes up by 1, which is good. It just increases by 1, okay? And my m, from here to here, I subtracted 3. From here to here, I subtracted 3. From here to here, I subtracted 3. Or I take my 4th value and subtract it to get this. My change, or my common difference, is 3. Now, a little hint. In this form, y equals mx plus b form, okay, m is always your slope, and b is always your y-intercept. So we'll write slope and y-intercept. And this is a great equation form. Your slope is always the change in the y divided by the change in the x. Literally, you subtract the 2 y values and you put it over the difference of the 2 x values. Well, look at what this would be. The change in the y's is -3 over the change in the x, which is 1. So my slope is -3, and that is what I put in for m. My y-intercept is always my initial value when my x value is 0, or my n value is 0. So my y-intercept, I just look where 0 is, and I find it. What is it? It's 1. That's where I start my y value, at 1, okay? That's my y-intercept. So Let's go ahead and write the equation first. It would look like this. Y equals 2. The slope, which is the change in the y's over the change in the x's, so negative 3 over 1, which is negative 3, times x, plus my y-intercept. Where x is 0, I get my y-intercept. There's my equation. Let's write it in words. And I wrote y and x, and let's go ahead and change that because we're not using x and y, we're using m's and n's, so I apologize. M equals 3n plus 1. So I would say the value for m is, that's is, negative 3 times the value of, sorry, it's not writing, hold on, of, oh, come on, you can do it, of, okay, is negative 3 times the value of n plus 1. So the value of m will be negative 3 times the value of n plus 1. Let's see if it works. Negative 3 times n, or negative 3 times 0, is 0, plus 1 is 1. Let's try it here. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. It works. Now we need a graph. So that graph would look something like this. Go ahead and draw a graph because I didn't give you one here. I apologize for that. But the graph would look like this. My y-intercept is at 1. My slope is negative 3, or negative 3 over 1. Let's give a few points here so we can graph them. So my slope is negative 3 over 1. Slope usually, ooh, I wrote an n, over 1. Slope is usually rise over run, but because it's negative, I fall. Okay, so I start at my y-intercept. I fall 3, 1, 2, 3, I run 1. And 2 points is enough to make a line. You could do a few more if you want. That's what the graph looks like. Now, I don't have to graph it like that. I could just graph these points. I could go 0, 1, then I could go over 1, down 2, which is that next point I already graphed. I could go over 2, down 5, and then over 3, down 8, and I'll still be on the line. And just connect the points, and there's your graph. All right, that's number 3. Okay, graph this function shown by this table and tell whether the function is linear or nonlinear. Really, all you need to do is graph it to tell. I will give you graphs for the actual test, by the way. I apologize that there are no graphs on here. But if I go ahead and sketch this out by hand, it's not very accurate. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. Let's see what it looks like. The first point is 0, negative 4. So I go over 0, down 1, 2, 3, 4. The second point would be over 1, up 2. Over 2, up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Over 2, up 8. And then over 3, up 14. That's totally off my graph. So this to me looks like it's a pretty straight line, even though the line I drew is not pretty straight. I apologize for that. Here's another way you can check. See if the change in y is constant. It has a constant slope. So from negative 4 to 2, I added 6. From 2 to 8, I added 6. From 8 to 14, I added 6. And the change in x, is it constant? It is. So the change in y over the change in x is constant. If this is not constant, then you're not linear, okay? So it is constant. It looks like I drew a straight line, sort of, in that picture. So it is linear. So I would graph this, and I would say linear. All right, so just check your graphs for the test. All right, we're going to write a rule that represents each function for number 5. My first instinct is to do a little table and see if I have a linear graph. And I can tell, remember, if the change is constant. So I have the point 0, 1, the point 1, 5, 2, 9, 3, 13, and 4, 17. Okay, the x's do increase by 1, so that is constant, by 1. And let's see about the y's. From 1 to 5, I add 4. From 5 to 9, I add 4. This is looking good. From 9 to 13, I add 4. From 13 to 17, I add 4. So it is constant. So remember, Because it is constant, I am linear, so I can use this. Y equals mx plus b. I can use this form whenever I have a constant change. So remember, my slope is my change in y over my change in x. Subtract the two y's, you get 4 over subtract the two x's, you get 1. That's how you get slope. Subtract the y's over subtract the x's. If it's constant, it will work. So there's my slope, 4 over 1, or 4. Okay. My y-intercept, that's always where my x is 0. So my y-intercept is right there at 1. Now I can write a rule. Y will be 4, my slope, 4 times x plus 1. So let's see if it works. Is y 4 times x plus 1? Well, 4 times 0 is 0. 0 plus 1 is 1. It is. Is y 4 times x plus 1? Well, let's check. 4 times my x value, which is 1, is 4. And then plus 1 is 5. It works. You can check them all, but there's my rule. Let's come over here and do a rule for this one. Okay, let's look at number 6 and try to tell if this is linear. One way you can tell if it's linear is to graph it. And I can already tell looking at it, it's not going to be linear. Let's go ahead and write our chart. We have 0, 1, 1, 3, 2, 9, 3, 27, 4, 81. So our x values increase by 1, that's good. But our y values, look, from 1 to 3 is 2. From 3 to 9 is 6. It already isn't linear because I don't have a constant here. You could graph this out and kind of get an idea. If you just graphed the point 0, 1, I go over 0, up 1. So if I just do a few points here. And okay, so if I do 0, 1, and then I do the point 1, 3, over 1, up 3. Then I go over 2 and I go all the way up 9. You can see it's going to go way up way fast. I go over 3. I go all the way up to 27. So my graph is like shooting up really fast. That to me looks exponential. I increase really quickly, really fast. You could also go to Desmos.com and graph some of these points. Let's go ahead and look. So we know it's not linear. What else could it be? How could I get from here to here? To get from 0 to 1, I could add 1, but that doesn't work for here. So let's look at something else. Let's see, because I don't have a constant here that increases, but I do see a pattern. I'm seeing a pattern. To get from 1 to 3, I multiply by 3. To get from 3 to 9, I'm just looking at these and thinking these are all multiples of 3. So that's giving me some kind of pattern. To get from here, I multiply by 3. To get from here to here, I multiply by 3. So if I was looking at a sequence, I would increase by a ratio of 3. I multiply by 3. So this is actually a geometric sequence. It's going to be exponential. So when I multiply by 3 to get to everything, let's look at this. From 0 to 1, well, how will I multiply by 3 to get from 0 to 1? Or to get from 1 to 3, maybe I could multiply by 3, but how do I get from 2 to 9 with a multiple of 3? Well, let's look at this. When we're looking at an exponential function, you're looking at the base to be 3. When any time there's a multiple of 3, that would be your base. So we might look at this. This would be our power. Anything to the 0 power, remember, is 1. So 3 to the 0 would give me out 1 for y. What about 3 to the first power? Well, 3 to the first power would give me out 3. What about 3 squared? That's 3 times 3. That would give me out 9. What's 3 cubed? Well, that's 3 times 3 times 3. That would give me out 27. So you can see I'm getting my values 1, 3, 9, 27, and I'm taking it to the power that is my x value. So my rule would look like this. My y value is going to equal my base of 3 raised to whatever x is, to the x power. So when I make x 0, I get out 1. When I make x 1, I get out 3. When I make x 2, I get out 9. When I make x 3, I get out 27. So this is the hardest type of rule. Anytime you can see a multiple here, a multiplier, if this is constant, this would be your base for an exponential function. You're going to take that base to the x. You may have to shift this and add 1 or subtract 2 or something at the end based on your zero power, but this is your basic graph, or excuse me, rule, your basic rule. All right, on to number 7. All right, 7, 8, 9, 10. Fill in the table of values for each function rule, then graph each function rule. This really should be easy ones for you guys. Just plug and chug numbers. So get your points here. All you are given all of these x values. All you have to do is plug them in to the function rule to get your y values. So this is just plug and chug. I'm going to plug in -2 in here. -2 times 5 is -10. -10 minus 2 is -12. Okay. If you're one that doesn't keep track of things very good, please write it out. Okay. So you're going to write 5 times -1 minus 2. 5 times -1 is -5. -5 minus 2 is -7. Then do 5 times 0 minus 2. 5 times 0 is 0. 0 minus 2 is -2. Plug in 1. 5 times 1 is 5. 5 minus 2 is 3. Plug in 2. 5 times 2 is 10. 10 minus 2 is 8. Okay, be very careful. Plug these in correctly. Use your order of operations. You plug this in, it gives you out your y value. Now, you now have all your y values and you can graph this. So I'm going to go -2 and then down 12. And it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's way down here. I know that one's off the graph. So -1 down 7, you end up about here. I hope. 1, 2, 3, 4, 5, 6. Yes, 7. All right, 0, -2. There's my next point. Over 1, up 3. Over 2, up 8. Okay. Now, technically, it's not just these dots. You're graphing this function rule. These are just points. All the points in between will be valid. This is not discrete. This would be continuous because it is a function rule. So please connect the dots. I think the graph, the answer key doesn't connect the dots, but it should, okay? Because this function rule, all the points in between would also be there. Please draw the line, all right? Let's go to this one. Just plug it in. -2. I plug in -2 for x. -2 times 3 is -6. -6 plus 1 would be -5. And I'm trying to get my writing tool to work. -5. Okay. -1 here. 3 times -1 plus 1 will give me out my y value. Just plug them in. 3 times -1 is -3. -3 plus 1 is -2. Plug in 0. This makes this 0, so I end up with 1. Plug in 1. That makes that 3. 3 plus 1 is 4. Plug in 2. 2 times 3 is 6. 6 plus 1 is 7. Graph your points. -2, -1, 2, 3, 4, 5. If you're accurate, these should be easy problems. -1 down 2. 0 up 1. Over 1 up 1, 2, 3, 4. And over 2 up 7. Emily, that's 4, 5, 6, 7. Okay, remember, it's this whole equation, so you should be able to graph the whole thing with the line. Even though the answer key doesn't give a line, please give a line. All right, there's your line. Now remember, I could graph this even without these points, but I want you to be able to plug and chug points. Because I could go, that's my y-intercept. My y-intercept is at 1. My slope is here next to the x. This is m, this is b. So my slope is 3, or 3 over 1. That means I rise 3, 1, 2, 3, I run 1. And it gives me that next point. Rise 1, 2, 3, run 1. Look at that, gives me all the points. You could even go down and back, because 3 over 1 is the same as -3 over -1. Oops, I need to write -1. A negative divided by a negative is a positive. So you could even go down 3, back 1, down 3, back 1. So it works. All right, absolute value. This one's a little trickier. That's the V shape. So I could take my V shape and shift it down 2 with this graph. I already know what this looks like. It looks like this before I even graph it. I already know, okay? Just because I know what the absolute value graph looks like and I know it shifts down 2. But plug it in. -2 into the absolute value. The absolute value of -2 is +2. Everything turns positive inside those bars. So I get +2 minus 2, which gives me 0. Plug in -1, turns it positive. 1 minus 2 gives me -1. Plug in 0. 0 minus 2 gives me -2. Plug in 1. 1 stays positive, and I go 1 minus 2, which is -1. Plug in 2. 2 is positive. 2 minus 2 is 0. So here's my points. I go -2, 0. I go -1, -1. I go 0. Excuse me, that wasn't a -1, -1. Sorry. -1, -1. I go 0, -2. I go over 1, down 1. And I go over 2, down 0. And look, there's the very graph I already told you it was going to be. Okay. Make sure you draw that. All right, on to the next one. We have an x cubed. What does that look like? It's going to be a snaky looking thing and then shift down 3. So I do my snaky shift down 3. I'm going to have something like this. That's the basic look of a x cubed graph. Just plug it in. -2. Careful with your negatives. I'm going to go -2 and then I'm going to cube it. Then subtract 3. Well, -2 times -2 is +4. Then +4 times another -2 is -8. So this will be -8 minus 3, which gives me -11. Plug in -1. -1 times -1 times -1 is -1. Whenever you have an odd exponent, you're going to end up negative if this is negative. So -1 minus 3 gives me -4. Plug in 0, 0 cubed is 0, minus 3 gives me -3. Plug in 1. 1 cubed is 1 times 1 times 1, which is 1. 1 minus 3 is -2. Then plug in 2. 2 times 2 times 2 is 8. 8 minus 3 is 5. Okay, there you have it. You're going to go -2 down 11, which is way down here off the graph. Okay. -1, -1, 2, 3, 4. You're going to go 0 down 1, 2, 3. You're going to go over 1 down 1, 2. And then you're going to go over 2 up 1, 2, 3, 4, 5. And that's going to give you your snaky-like graph that looks something like that. So please connect the dots. All right, on to the next. Okay, this graph the function rule tell whether the graph is continuous or graph the function rule. Tell whether the graph is continuous or discrete. Make sure you do both those things, okay? Graph the function rule and tell whether it's continuous or discrete. So 2 things to do, okay? So they give you information. The price P in dollars for apples depends on the weight in pounds of the apple. Here's the rule. They give you the rule. So here's how I want you guys to do this. Make a little chart for your rule, an XY chart, or in this case, it will be a PW chart. Your weight will be your X value, because your price for your apples depends on how many apples you buy. So the weight of the apples. If you go to the grocery store, you'll see this often. Apples are $1.99 a pound. Apples are $2.57 a pound. So you pay for how many pounds of apples you buy. So if I buy 0 apples, I pay nothing. Okay, plug in 0 for weight. I pay nothing. You're not going to do a negative weight. That doesn't make sense because you're not going to buy a negative weight of apples. So don't do negatives, only positives. So let's go to 1 pound. If I buy 1 pound of apples, I'm going to pay 1 times $1.99 is $1.99 in price. If I buy 2 pounds of apples, let's go 2 times $1.99. What's that going to be? $3.98 in price. If I go 3 pounds of apples, 3 times $1.99, $5.97. Okay, so that's how much I would pay. Now, that's how I'm going to graph. Let's go ahead and graph. And before we finish our graph, we're going to do our weight for my x-axis and then price for my y. So my weight was 1 pound, 2 pounds, 3 pounds. And up here we had Let's go $1, $2, $3, $4, $5, $6. So we'll just go 1, 2, 3, and so on. So at 1 pound, I have almost $2. At 2 pounds, I have almost $4. At 3 pounds, I have almost $6. So 1, 2, 3, 4. Here's 6. So at 3 pounds, I have almost $6. So there's a graph, but now I have to stop and go continuous or discrete. Continuous means I can draw a line through this, and that's because I can do anything in between 1, 2, and 3 pounds. I can do a half a pound. Oh, half a pound would be over here. Or 1.5 pounds, or 2.5 pounds. Continuous means I can find all the spots in between these whole numbers. Well, let's check and see if that's viable. Can I connect the dots with a continuous line or not? Discrete means only dots, or only whole points, okay? Continuous means connect your graph, okay? Continue, all right? You get the whole line, you get all the half points in between. Well, check. I only did 1 pound, 2 pound, 3 pounds, but is it possible for me to buy a half a pound of apples? Sure, maybe I pick up 2 apples and they're pretty light and they're only a half a pound, okay? If I plug in a half a pound, 1.99 times a half a pound is going to give me 0.995 or about 99 cents. So a half a pound, I'm going to pay a little less than $1. So look, I can do a quarter of a pound. I can do 1.5 pounds. I could do 2.5 pounds. I could do 2.25 pounds. I can get all these little dots in between. So I'm going to be able to connect this graph. This is a continuous graph. It starts at 0 and it goes up. Okay, no arrow that way. It's continuous because I can get fractional pieces in here in order to connect all the dots. Now, how do you know if it's discrete? If I say you only want, instead of saying the price in dollars for apples depends on the weight in pounds, what if I said the price in dollars for apples depends on the number of apples? Only whole apples, okay? If I could only do whole apples, I would be discrete. The reason would be because here wouldn't be weight, it would be number of apples. Okay. I couldn't buy, well, I'm not going to buy half an apple because once they cut open an apple, it gets gross. So you're only going to buy whole number pieces. If you only bought whole number pieces, then you would only have dots on your graph, and that would be discrete. So check what you have. Do you only have whole things? That's discrete. If you have something like weight where you can get fractional pieces, you're going to be able to draw a line through it and it can get continuous. So when you're doing number 11, first graph the rule, draw out some points, go ahead and make some dots, and then go back and look, am I continuous or discrete? Could I do fractional pieces here and connect my dots, or do I only want whole numbers? It depends on what you're talking about. You have to look at the situation. On to number 12. Number 12, write a function rule that represents each sentence. So really just write out what you're hearing. This is just translating verbal to equation. Z is an equal sign. So I'm going to go Z is 6 more than 6 plus twice Y, 2Y. It's easy as that. Read it, write it. The total fees of a book club, and then fees they said was F, of a book club membership are $10 per month and a one-time administration fee of $4.75. So my fees are going to be $10 for every month, so 10 times the number of months, plus a one-time admin fee of $4.75. There you go. All right, let's go to this one. 5 less than 1/4 of x is y. Is your equal. Okay. 5 less than 1/4 of x. Whenever you have a less than, hold on to that. Let's go 1/4 of x. So 1/4 of is a multiply. 1/4 of x. So I'm going to take 1/4 and multiply by x. And I want 5 less than that. I want 5 less than 1/4 x. It is y. Okay. All right, a babysitter's earnings are, let's scroll this up. hold on, scroll up. Let's clear that. A babysitter earnings are E, or babysitting earnings E, are a function of the number of hours worked, N, at a rate of $7.25 per hour. So the earnings is just going to be the number of hours worked. They said N is the number of hours worked times 725. So 725 times the number of hours you worked is your earnings. And that's all it is, guys. All right, this one, write a function rule for the area of a triangle with a base 2 meters less than 4 times its height. What is the area of the triangle when the height is 8? This one's a little trickier. Write out what you see. A function for the area of a triangle with the base 2 meters, so the base is going to be 2 meters less than 4 times the height. So I'm going to take 4, I'm going to multiply it by the height, and I'm going to subtract off 2 meters, okay? So it's 2 meters less than. Anytime you have the 2 less than, hold on to it, do the 4 times the height and subtract off your 2. That's your base. What's the area of a triangle when its height is 8? Well, let's write out the formula for the area of a triangle. Area of a triangle, you should know, is 1/2 times the base times the height. That's the area of a triangle. All right. So if I know the base is 4 times the height minus 2, I'm going to go like this. Plug this in for the base. And now I'm writing a function rule for the area of a triangle in terms of the height only. So the area of a triangle is going to equal 1/2. The base is actually going to be 4 times your height minus 2. That's what the base is, and then I multiply that times the height. So here I have a function rule for the area of a triangle in terms of the height only, and they give me the height is 8 meters. So now I can plug in 8 for the h's and solve this. So plug in 8 here for height and plug in 8 here for height and do this problem. I'm going to work it down here because I wrote too big. So let's go A equals 1/2, and then that's going to be 4 times 8. And 8 times 4 is 32. So I'm just going to write 32 minus 2. And then this is 8. Do what's in parentheses first. Remember, 32 minus 2 is 30. So this is going to be 1/2 times 30 times 8. Well, let's go 1/2 times 30. Well, half of 30 is 15. So I'm going to go 15 times 8. And what is that? I don't know. 15 times 8 is 120. And 15 times 8 is 120. So your area when the height is 8 is 120. Okay, another way you could have done this is you could have gone area is 1/2 base times height. And if you knew the height was 8, you could have come and plugged it in here. You could have gone 8 times 4 is 32. 32 minus 2 is 30. So you would have gone the base is 30 and the height is 8. So just come over here and you could have gone area is 1/2 times your base, which is 30, times your height, which is 8, which is what we ended up getting right here anyways. So you could have done it that way. But we want to see this, okay? We want to see this. That's your function. I'm just going to add on one more thing. I left off the meters. It is meters squared because if this is in meters and 8 is also in meters, if you do meters, or right here, meters times meters, you get meters squared. Remember, area is always in square units. My husband, who's an engineer, would kill me for not attaching the units. Okay, identify the domain and range of each relation. Use a mapping diagram to determine whether each relation is a function. So make sure you do everything it says. Identify the domain and range. Use a mapping and tell me if it's a function. You've got 3 things to do here for both problems. So first, domain and range. Let's go ahead and start out by writing things out in a mapping, but your domain is always your x values. So I would start out by going, my domain is all my x values. So they are 6, 5, 2, and I don't have to write 2 twice. There's 2 2's. Whenever there's 2 x values that are the same, that should be a red flag. Okay, so I can already tell you right now this is not going to be a function because my x value is repeated. All right, the range. The range is 5, 6, 2, and 6 again. I don't need to write it twice. It's already in my values there. Now my mapping. Okay, my mapping would look like this. I put my x values here and my y values here. So my x values, I like to put them in order. I like to go 2, then 5, then 6. And my y values, I'm going to put those in order too. Same numbers, 2, 5, and 6. Okay. And then I'm going to go up and see how they map. 6 goes to 5. Good. 5 goes to 6. 2 goes to 2. And 2 also goes to 6. Red flag. Anytime I have an arrow that goes to two numbers, I don't have a function. And this is how you know. I have a function box. It's some relation like y equals x plus 2. So what that means is I take an x value, I plug it in, I do the function to it, and it spits out a y value. Okay. So if I take 6, I plug it into my special box, it spits out 5. I take 5, I plug it in my box, it spits out 6. I take 2, I plug it in my box, it spits out 2. I take 2 again, I plug it into my box, and this time the box changed its mind and it spit out 6. First it told me if when I plug in 2 I get 2, then it told me when I plug in 2 I get out 6. That's not functional. It changed its mind. Every time I plug in 2, it better spit out the same number, but it didn't. It spit out 6. So anytime the x values repeat, and if they do not have the same y value, like I get out 2 and I plug in 2 again, I better get out 2 the next time. I should always get out the same number. Anytime I have the same x value and different y values, you are not a function. So look at a mapping. Does one x value go to two y values? You're not a function. Okay, that's how you tell. The y values are allowed to repeat. I can plug in 6 and get out 5. I could plug in 5 and get out 5. I could have two of the same y values. That's fine. If I plug in something and it spits out the same answer for two people, that's fine. But if I ask you the same question and you change your mind on the answer, that's not okay. So you're looking for the x values to see if those x values repeat. Does the x value repeat? If it does, it better repeat the y value or you have a problem. Okay, let's go ahead and look at these guys. You got some decimals here, it's fine. Domain, just your x values, 0, 1, 2, and 3. Range is just your y values, 0.4, 0.8, 1.2, 1.6. So 0.4, 0.8, 1.2, 1.6. Your mapping over here. So, sorry, I lost my pen. Your mapping would look like this. 0, 1, 2, 3. And then you're going to have 0.4, 0.8, 1.2, 1.6. I can already tell this is a function because look, the x values don't repeat. There's no 2 twice or 1 twice. That gives me a different y value. None of the x values are all different, so I am going to be a function. I'm going to put yes already and go ahead and circle it. Yes, it is a function. So let's go ahead and map. 0 goes to 4, 1 goes to 8, 2 goes to 1.2, 3 goes to 1.6, straight over, and that's what that looks like. Okay, so just double check your x values, see if they repeat. The y values can repeat, just not the x values. If the x values repeat, it better be the same point, right? You can also tell if it's a function if you graph it. If I graph something like this, and I do the vertical line test, and it only touches once, no matter where I draw a vertical line, it only touches once. If I have a graph like this, and I draw a line through, and it touches twice, that means I have the same x value for two different y values. That's not okay. Not a function. Okay, on to the next one. Describe the pattern in the sequence, then find the next two terms of the sequence. So let's look at our sequence. And remember, sequences can be brought into equations of lines. They're connected because that common difference is going to end up being your slope. So let's look if this is term 1, term 2, term 3, term 4. Okay. So to get from here to here, 6.8 to 5.4. Okay. That's a subtraction of 1.4. To get from 5.4 to 4, once again, I subtract 1.4. To get from 4 to 2.6, I'm going to subtract 1.4. So, describe the pattern. I'm going to subtract 1.4 or minus 1.4. What are the next two terms? So that's the first answer. And the next two terms are going to be 2.6 minus 1.4 is going to give me 1.2. Then 1.2 minus 1.4, that's going to give me negative 0.2. Okay. Let's do the same thing here. And that's my second part of my answer. Let's see if there's a common difference or a common ratio here from 9 to 15. So let's see. From 9 to 15, I'm going to add 6. From 15 to 21, I add 6. From 21 to 27, I add 6. So it looks like my pattern is add 6. Okay. Find the next two terms. Well, 27 plus 6 is 33. 33 plus 6 is 39. So there's my next two terms. Okay, there we have it. Let's go ahead and look at the next thing. Tell whether the sequence is arithmetic. If it is, identify the common difference. So we just did that with those. Those two would be arithmetic. They do have a common difference. Let's see if these are arithmetic. We can tell if they have a common difference. If they have a common ratio, they would be a geometric sequence. Let's check. From 7 to -5. Let's see. If I go from 7 to -5, 7 minus -5, I'm going to take off 12. Okay, that difference is 12 in the negative direction. From -5 to -17, I subtract 12. From -17 to -29, I subtract 12. So yes, it is arithmetic. Yes, arithmetic. Okay, so identify its common difference. Its common difference is -12. Okay, let's check this one. To get from 2 to 4, I would add 2. To get from 4 to 7, I add 3. To get from 7 to 9, I add 2. Well, I added 2, then I added 3, then I added 2. So does this have a common difference? No. So it's not arithmetic. All right, that's a no. Okay, let's go to 23. You start an investment account with 3,000 and you save 100 each month. Write an explicit formula to represent the total amount of money you invest into your account as an arithmetic sequence. How much money will you have after 12 months invested? You really could figure this out without writing the explicit formula, but we want you to show how you could use this. So if I just were to figure this out without writing an explicit formula, I would go, all right, I start my account. Let's just make an XY table here. I lost my mouse and my table. Hold on, try again. Okay. Let's just say I haven't started saving. So the first month, if X is months, that's your X, and Y is the amount in your account. So your Y is your dollars. Okay. So at 0 months, you haven't started saving. This is your initial amount. Okay. After the first month, you've saved $100. So you would have $3,100. After the second month, you would have $3,200. Third month, you would have 3,300. And the fourth month, and so on, you would have 3,400. So you could go all the way down to the 12th month. Just keep saving it, just keep going, right? All the way down. So at the 12th month, you're going to actually end up with 4,200 if I just keep adding this way. So I can figure out how much you have invested after 12 months, 4,200, because we're not talking about compound interest or anything, just how much is in your account without the interest, okay? Now, if I want to write an explicit formula, the reason I would do that is, what if I said, how much is my account after 42 months? I don't want to add this all up after 42 months. Let's write a formula that will figure that out for us. Now, I ask you for the explicit formula, and then I ask you for how much after 12 months. Make sure you answer both questions. The explicit formula looks like this. Any term equals, you're going to tell me what the first term is, okay? So A sub 1 is your first term, and then you're going to add on 1 less than that, so n minus 1 times the common difference. Why is that? So any term, your third term, let's say I wanted your third term, that would equal your first term, which is here, plus the number of terms. So if I wanted my third term, I would start with my first term, and then I would add 3 minus 2 times the common difference. To get from the first term to the third term, I add my common difference of 100 twice. So that's why I do n minus 1 instead of doing n times the common difference. I don't want to get to my third term by adding my common difference 3 times. I get to my third term by adding my common difference twice. I get to my fourth term by adding my common difference 3 times. I get to my 12th term by adding my common difference 11 times. 1 less times the common difference. So I start with my first term, 1 less than the common difference, and that will be the number of times I add it, okay? So that's where this comes from. 1 less than the common difference, add that to your first term. So my explicit formula looks like this. Any term will be my first term. Now careful, a lot of people think 3,000 is your first term. That's before I do anything. When I do my first month, I actually have 3,100. Okay, that's the tricky thing about the first term. It's 3,100 plus the number of terms or the number of months minus 1 times that common difference of $100. Now, if you give me this formula, I'll give you full credit. If you want to simplify, you would multiply 100 times n and 100 times 1, and it would look like this. 3,100 plus 100 times n is 100n, and 100 times 1 is minus 100. Now simplify this. 3,100 minus 100 is 3,000 plus 100n. Okay, that is your arithmetic sequence. Now look, this actually, if I put the 100n first, I'm just going to write this down here so you guys can see the connection. 100n plus 3,000. This is slope-intercept form. Y equals mx plus b. Your slope, look, is your common difference. And your b, or your zero term, is 3,000. That's your zero term. That's your common difference. So the arithmetic sequence, simplified, is actually slope-intercept form. It's all connected. All right, so just a little tidbit on that. Let me erase that. Now, if you give me the arithmetic sequence in this form or in this form, both are fine. Just know the explicit formula looks like this. This is in raw form, this is in simplified form. Now, in simplified form, it's really easy to get just by looking at the equation, just so you know. I could have gone, all right, any number, any month, you're going to get by starting with $3,000, and you're going to add $100 times the number of months. So look, I just read this how it's written, and it already gave me the simplified form of the explicit formula. Look at that. How easy is that? Check it, okay? So I want 12 months, so a sub 12 is going to be 3,000 plus 100 times 12. Do the math, okay? 100 times 12, you just add 2 zeros to that. It's going to be 1,200. You're going to add 3,000 to that, and it's going to give you 4,200. Okay? So, which is what you would get if you just added it down. So give me the explicit formula, either this one or this one. You could write it out just by seeing how it's read logically. It is the explicit formula. And then give me the solution, 4,200. All right, guys, just be careful. Your first term isn't always the term they give you. That was the zero term. Our first term, the first month, is actually 3,100. A lot of students put this as their first term. They put the 3,000. That's actually your zero term. Careful. Okay, find the 4, 6, and 13 terms of the sequence described by this explicit formula. So remember, explicit formulas, just to go over this, you don't even have to worry about this, but just so any term will equal 12 is your first term. That's a sub 1, okay? Plus whatever the number of terms is minus 1, and then 5 is your common difference, okay? So that's what this is. Oh, that was D. I'm writing out the general formula, okay? So 5 was my common difference. 12 was my first term, not my zero term, okay? Not my zero term. So when I multiply this out, it ends up being in slope-intercept form, and it will end up giving me my zero term because I have this n minus 1, okay? Careful. All you have to do for this is find the 4th, 6th, and 13th terms. So I'm going to go a sub 4. The fourth term is going to be 12 plus, I plug in 4 for the number of terms, 4 minus 1 times 5. Just do the math. 4 minus 1 is 3. 3 times 5 is 15. 15 plus 12 is 27. Okay, so there's A4. Now do A6. A sub 6. Just plug it in. This is plug and chug. This should be easy problems here for you guys. 12 plus 6 minus 1 times 5. Okay, 6 minus 1 is 5. 5 times 5 is 25. 25 plus 12 is 37. Okay, so 37, 27. Circle your answers for me. And the last one is a sub 13. That's a 13, sorry. That would be 12 plus 13 minus 1 times 5. 13 minus 1 is 12. 12 times 5 is 60. 60 plus 12 would be 72. Okay? So this is just making sure you understand how to find any term. If you have the 13th term, whatever, understand this explicit formula. That's your first term. That's your common difference. This n stands for the number of terms you want. Okay? 25 is the same thing. Find the 3rd, 5th, and 10th terms of the sequence described by this. Remember, if I distribute this, this ends up in slope-intercept form. If I just show you how to do that, if I distribute this, this would be 2 plus 6n minus 6. And if I simplified this, that's what a sub n is. If I simplify this, 2 minus 6 is negative 4. So 6n minus 4. Okay, that's what a sub n equals. And I just lost my pen. Look at that. And it's still not back. And one more try. There we go. And that's in slope-intercept form. There's your slope. There's your y-intercept. That is your 0 term because I took it off right here. Okay. Remember, when you're in explicit form, that's your first term, not your 0 term. That's your common difference, which end up being your slope. Okay. All right. Let's just remembering this. I just want you to know. All right. Find your 3rd, 5th, and 10th term. So 3rd term, I'm just going to go a sub 3 equals 2 plus, I plug in 3 for my number of terms, and times that by 6. Just plug and chug. These are really easy. 3 minus 1 is 2. 2 times 6 is 12. 12 plus 2 is 14. There's your first answer. A sub 5 is 2 plus 5 minus 1. 5 minus 1 times 6. 5 minus 1 is 4. 4 times 6 is 24. 24 plus 2 is 26. Super easy. And then a sub 10, just plug in 10. I said 10. 10 minus 1, 10 minus 1 times 6. Do the math. 10 minus 1 is 9. 9 times 6 is 54. 54 plus 2 is 56. And you're done, guys. Right, that's the whole test. Good luck. Email me if you have any questions.